Here we do have a data sufficiency question, which on the first look looks a little bit difficult, but if we go through it step by step, we can manage. Is the 12-digit positive integer a perfect square? Statement 1. The number comprises only the digits 0, 1, and 2, each written 4 times. Statement 2. The sum of the digits of the 12-digit number is 12. Pause the video and have a go at yourself. Alright, let's look at it together. So what's important here is that we have a positive integer, which is a perfect square. A perfect square means that the number is the square of another integer. Let's call this number n squared. Let's have a look at a little bit of number theory to make it easier. So we've got n squared as our number, and n we can divide into its prime factors. For example, p and q. For example, if n squared would be 225, then this would obviously be 15, and the prime numbers or the prime factors would be 3 times 5. Now, if we square n, that means as well that we square the prime factors. So 225 has to be divisible by 3 squared, or 9, and 5 squared, 25. And this is what we need to solve this question. Let's look at statement 1. Okay, so 12-digit number, it could look like this, or it could look like this, or really any other combination. Is there any way we can find one of the prime factors? Well, there are a few numbers which make it easier. So for example, the prime factor 3, we know that a number is divisible by 3 if the sum of the individual digits is divisible by 3. Let's look at the sum here. So, all right, this sums up to 3, so there's another 3, 3, 3. So the sum of the digits is 12, which is divisible by 3. That is correct. So 3 is a prime factor of n. Now, if it's a prime factor of n, that means that 3 squared should be a prime factor of n squared. That is 9. How can we find out if a number is divisible by 9? Well, a number is divisible by 9 is if the sum of the digits is divisible by 9, and we know that sum is 12, which is not divisible by 9. Therefore, this statement alone is sufficient, and we know that this integer is not a perfect square. Perfect. So, check. This eliminates B, this eliminates C, and it eliminates E. Now we have to decide between A and D. Let's look at statement 2. The sum of the digits of the 12-digit number is 12. Well, that is just a shortcut to this here again. If it's 12, we know that it's divisible by 3, but not divisible by 9. And therefore we know it's not a perfect square. The correct answer, therefore, is D. Each statement is independently sufficient.